This video lecture supplements a workbook for Beck's Introduction to SQL Programming, the Pelican Companion. The corresponding textbook is Beck's Introduction to SQL Programming, that Pelican database book. The workbook and printed copy of the companion textbook may be purchased from lulu.com. You may download the textbook for free in ebook format from beckplanet.com/books. Important note on SQL Server and MySQL. The material presented supports both the SQL Server and MySQL environments. Where differences in SQL dialect and environment arise, solutions for both environments will be demonstrated. Where the SQL code is common across environments, only one environment is used for demonstration, as the code runs identically in the other environment. Chapter 3, Parallel Exercises. Solution Walkthrough with Commentary. Parallel Exercise 1. Using the Candy database, use the count operator to show how many clients, in total, are served by sales agent number 3 or number 4. As with previous lessons, we will start off with the example of using a SQL template to help us make a start, and we will iteratively build the query by refining it as we go. We will start very broadly by selecting everything. You will notice I have simplified the template somewhat. Soon, if not already, you will be so accustomed to this that you will no longer need to use it. Next, we will refine the query by adding the where filter. Finally, we will revise the select clause to generate only the required count. Parallel exercise 2. Using the Candy database, use a subquery to list only the product num, description, and price of each candy whose price is less than the average price for all candies. A careful analysis of this problem shows us that we need to use a subquery in order to determine the value of the average price from the product table. Then we can use an outer query to match that price. So we'll start by building the innermost query first. And again, we'll get there using our template. Having determined the value of the average price that we need, we will then use that in the where clause of the outer query. Finally, we'll reduce the selected output to only the displayed fields. Parallel exercise 3. Using the Candy database, use a subquery to display the product number, description, and price of the highest priced candy or candies in the database. An analysis of the problem statement of exercise 3 shows us that once again, we will need to use a subquery and first determine the maximum price from the product table. Having determined an expression for the maximum price, we can now nest that into a subquery. Finally, we will reduce the displayed output to only the required fields. Parallel exercise 4. Using the Candy database, use the order prod table to list the order number and sum of the quantity of items ordered for each order number. Group the results by order number and order them descending by the sum of the quantity ordered. Use an appropriate halving clause to show results only for order quantities more than 1,500. Exercise 4 differs somewhat from the exercises we've seen so far. We're going to need to use grouping. Let's use a slightly modified template for this. Things start out well. However, we generate an error when we try to select star with a grouping of order num. This is because we have fields in the selection that are not part of the group by clause. Usually, we wait to reduce the selected fields until the end. Here, we're going to have to reduce the fields initially. Now it works, but we haven't added in the sum of the quantity ordered. Let's add the aggregate function. The aggregate function works as part of the select for the group by. The equivalent of the where clause when using group by is halving. Halving is where we will do our filtering. Here, we are filtering the results to only those results having the sum of the quantity ordered greater than 1,500. This is working. Now we simply have to add the sort order. Parallel exercise 5. Using the Candy database, use the order prod table to list the product number and count of each candy that has ever been ordered. Group the results by product number and arrange them ascending by the product number. Limit the output to only those candies that have been ordered 6 times or more using an appropriate halving clause. Here is another problem requiring grouping. Let's see if we can take our game to the next level by starting out with the first three statements of the query rather than having to select all or select star to begin with. We want to select something from order prod, and we're going to group by the product num. The items we need to select are product num and the aggregate count. Let's test this. That's working, counting, and grouping as desired. Now let's filter. This should filter for only counts that are more than or equal to 6. That's working. Finally, add the sorting. Parallel exercise 6. Using the Candy database, list the order number and order date of all orders that were ordered after April 1, 2012. Order the results by the order date. Exercise 6 is a straightforward query, except that it's using a date for filtering and ordering. The key to using a date properly is to make sure that the date is expressed either in proper date format or as an expression or format that can be implicitly converted to a proper date format by the database management system that you are using. With the filter working as desired, we can add the sorting. Parallel exercise 7. In order to promote additional sales for the quarter, management is considering decreasing the price of all candies by 13.75%. Using the Candy database, list the product number, description, and new price for all candies. Use sale_price as the name for the computed column. Let's skip ahead just a bit and format the calculated field as currency. Exercise 7 calls for us to use a format expression to format a calculation or number as currency. This is handled a little bit differently in SQL Server and in MySQL, and it's addressed actually in later chapters of the book. So let's take a look ahead and see how we can format the expression as currency. We'll start with SQL Server. So I have a select statement pending, and then we're going to introduce a format statement. And in SQL Server, the format statement looks like this. Format, and then you will need some expression, and then we're going to use the constant C for currency, and we're going to tell it that the region is EN US, so English US currency, which will give us dollars by default. So you can see there's some internationalization bound up with this, so you can use different currencies and localize your code appropriately. All right, so let's take a look at this expression. That could be just a constant expression like 99.214. And if we run that, we get a dollar sign and then a decimal and 2 decimal places following it, as we would expect for US currency. And of course, this can be a variable, it could be a field name, or it could be a more complex expression. And so let's demonstrate that. So here, just sort of arbitrarily, 3.14 times 21 divided 7 plus 19.3581, just to demonstrate that we can have more numeric precision in here than is displayed in the formatting. And we run that, and the results are $28.78. Now that we've learned how to use the format function to format currency in SQL Server, let's go ahead and focus on the query. So we are going to select the product number, the description, and we're going to have a calculation here. It's going to be price, and we're taking a discount. So the discount here is going to result in a coefficient of 0.8625. And we're going to alias that as sale underscore price. And we're selecting that from the product table. Okay, that appears to be working. Now we need to take the sale price column that we are creating and convert this calculation so that it is formatted as currency. So again, we'll take the format of this expression as C, the constant denoting in SQL Server currency, and the localization is English US units, another constant, and close that expression and close the format function, and then our alias to sale underscore price follows. Oh, one too many parentheses. Let's correct that, and there we go. Now let's see how we can do currency formatting in the MySQL environment. This is done with concatenation. So we'll start with concat, and we're going to concatenate or stick together the dollar sign at the start of currency. And then we can use MySQL's version of the format function. And we would put whatever our expression is there and specify that we want 2 decimal places. And so let's put an arbitrary value in here. How about 23.1987 and run it. And we see that that formats to the 2 decimal place with the dollar sign that we want. So we can, of course, replace this with any expression that evaluates to a numeric value. So multiply that by 3 and divide it by 7 and whatever else you can imagine. And as long as that is a variable, field name, or expression that evaluates to a numeric value, our formatting to currency in MySQL should operate correctly. Aside from the formatting, the SQL logic is essentially the same in the MySQL environment as in the SQL Server environment. So we can start with our select and select our product num, our description, and our price time the coefficient for the discount. From the product table. And let's remember to alias our calculated field as sale underscore price. Let's test that. And that's working. And now we just need to add the formatting appropriate to MySQL. Concatenate a dollar sign to the beginning. And format the expression to 2 decimal places. And there we are. Parallel exercise 8. Using the candy database, list the product number, description, and price of each candy that was not manufactured by any of the following manufacturers: 5, 7, 10, 11, 12, 19, or 22. Do not list the manufacturer number in the output. Use the IN operator to achieve this. Exercise 8 once again demonstrates for us that in SQL, sometimes the most efficient way to express a logic condition is by exclusion. So we will use a NOT operator, and we'll also use the IN operator, which is a more efficient way of parsing through a comma-separated list rather than having to go through a long string of Boolean OR conditions. So let's see, we want to select some things from the product table where the manufacturer number is not in the list 5, 7, 10, 11, 12, 19, or 22. That looks good. Now let's trim down to just the fields that are required by the specification for display. Product num, description, and price. There we are. Parallel exercise 9. Using the candy database, use the count operator and the in operator to determine how many clients in total, for example, we want just one number from this query, live in the postal code 91356, 91405, or 93001. Exercise 9 is a straightforward count of records with a filter. Let's start with the count. The entire table contains 12 records. Now let's add our filter. We're filtering for the postal code is in the list 91356, 91405, or 93001. And the count is 6 records. Parallel exercise 10. Using the CANDY database, list postal code and the count of how many clients reside in that postal code, where that count is more than 1. Hint, your query should display 2 columns, postal code and the column containing the count of customers residing in that postal code. Use a having clause to filter results for only those postal codes with more than 1 customer in them. Exercise 10 will require a grouping and a filter using a having clause. Let's start by selecting the postal code from the client table. Let's group by the postal code. And add the aggregate count. Now let's add a filter to the having clause, looking for count more than 1. Parallel exercise 11. Using the CANDY database, determine how many clients, in total, live within zip codes below 91400 or above 93000. Hint, use the count keyword and your result should display just one number, nothing else. Exercise 11 is a simple count query with a where clause filter involving a Boolean OR. Let's take a look. Here's a select star, and we'll refine that. We see that select star gives us 12 rows. A count with no filter should also return a count of 12. It does. Now we can add our filter. Here's our filter of the range of postal codes that are less than 91400 or more than 93000. Parallel exercise 12. Using the CANDY database, list each product num and the count of orders for this candy for which the count of orders was more than 5. Note, the count of orders is different from how many times a piece of candy was ordered. If we wanted the piece count, we would need to multiply by the quantity ordered, but that is not what this exercise requires. Order the output ascending by product number. Hint, the solution requires a group by clause and a having clause. Exercise 12 is a straightforward grouping and counting problem with an order clause thrown in for good measure. Let's start by selecting product num from the order prod table, and we'll group by product num. So far, so good. Let's add the count of order num. And that's working. Let's restrict this with a halving filter. Where the count of order num is more than 5. And we conclude by adding the sort clause. Parallel exercise 13. The Vice President of Sales is considering a price increase of all candy by 12% for those candies that have a current price less than 21 cents. Using the candy database, list the product number, description, and the calculated price field, alias this field new_price, for those candies that meet this criterion. Format the calculated field as currency. Exercise 13 is a straightforward select query. We'll be doing some formatting, so we'll see again the use of formatting in MySQL and formatting in SQL Server. Let's go ahead and make a note that we're starting with the SQL Server version. And we'll start out by selecting everything from product where price is less than 21 cents. Very good. Now let's work on our select clause, reducing that to the product num, the description, the price, and the expression price times 1.12, and we'll alias that calculated field as new_price. Forgotten the multiplication operator there. Make that correction. Very good. All right, so we've met the requirements except for our formatting. So this will be the same query in either SQL Server or MySQL, but the formatting is going to be a little bit different to render currency as we've seen before. So let's start out with this as SQL Server. We'll format this expression as currency in English US units, that is to say the dollar. And that is the solution for SQL Server. And through the magic of video editing, I have reconnected my SQL client, which is the Heidi SQL client, if you're curious. Heidi will work with either SQL Server or MySQL, and that's one of the reasons I'm using it for these demonstrations. So I've reconnected to MySQL, and so let's change our label. This is no longer the SQL Server version, this is the MySQL version. And all we need to do is to change the format function and we'll render that appropriate for the MySQL environment. So here is the expression we'd like to work with. And so we will add the concatenation function, concat, and we will stick a $ symbol to the beginning and then format the remaining numeric expression as 2 decimal places. Continue to alias that as new price, and that should be all that's required. Let's test it. Nice. Parallel exercise 14. What are the highest, lowest, and average price of candies by each manufacturer? Using the candy database, display each manufacturer number and order the output by manufacturer number and label the calculated fields highest underscore price, lowest underscore price, and average underscore price, respectively. Format the average underscore price as currency. Note, it is possible for the highest, lowest, and average price candy for a given manufacturer to be the same. Exercise 14 is another situation where we're going to do a group by. We're also going to do some ordering. And the only real twist with this exercise is that we're going to use multiple aggregate functions because we're going to provide the maximum, the minimum, and the average price in the aggregates for the groupings. So this will also use a formatting, and so we'll have a version here for SQL Server and a version for MySQL due to the differences in the string handling for the format. Okay, so let's get started. Let's start by selecting the manufacturer number from the product table, and let's group on that manufacturer number. So far, so good. And now we need to add in the aggregation. So we'd like the maximum of price, and we're going to alias that as highest underscore price. Let's test that. Okay, that's working. And we're also going to add the minimum price, and we're going to alias that as lowest underscore price. Give that a test. So far, so good. And finally, let's have the average price, and we're going to alias that as avg underscore price and test that. Okay, so our logic is essentially complete. Now we just need to do the formatting because our requirement here is to format the average price as currency. So let's go ahead and add that in for SQL Server, and then we'll transform that for MySQL as well. So let's take the average price take that expression as currency in English EN-US, English US units. Oh, didn't balance my parentheses. There we go.
And finally, we'll add in the ordering. And we'll order by manufacturer number. And there we go. There's our solution for SQL Server. Through the magic of video editing, I've reconnected my SQL client to the MySQL engine. And now let's transform this code over to use MySQL for formatting. So we'll strip the old formatting from the SQL Server version down to bare bones expression of the average price. And now we need to take that expression and format it as we do in MySQL. So let's go ahead and concatenate a leading $sign. And let's format the average price expression as 2 decimal places. And there we have the solution for MySQL.
Parallel exercise 15. The marketing manager has a strategy to get clients to be more aware of the newly expanded candy lines the company is offering. To get buyers to study the names, descriptions, of all the candies the firm sells, she wants to offer a promotional sale price of 1-cent piece price of any candy for which the client can build the word "yum" from letters found in the candy's description. The manager has asked you to use the candy database to create a list of all candies that you sell that qualify for the promotion. Any candy description which contains all the letters Y, U, and M anywhere in the description and in any order should appear on your promotions list of the product number, description, and the calculated promotional price labeled yum_price. Format the calculated field as currency. If your database system is configured to be case sensitive, use the lower function on the description.
Exercise 15 is actually a straightforward select query with the twist that we have to properly analyze the filter so that our where clause gives us results where the description field contains simultaneously 3 things. It has to contain a Y, it has to contain a U, and it has to contain an M. In any order, any number, any combination, as long as all 3 of those letters occur at least once. And that's where we have to think about how to do that. So let's work through this. Let's start with our select clause. We want the product num, the description, and we're going to have 1 cent as the yum_price, working from the product table. Let's test our solution so far. Okay, fine. Now, let's add some pseudocode to help us structure the code we want to create. This is a common tool of programmers to write pseudocode to help to create or extend their template for the code they have to craft. And so let's do that, and we need to say, well, where what? We need description has a Y, and we need to say description has a U, and we need to say description has an M. And these 3 things have to be true simultaneously. So how do we do that simultaneously? Okay, that means that this is true and the next criteria is true and the next criteria is true. Think about it. You want and rather than or, because if it had Y or U or M, then any one of those letters would qualify. And that's not what we want. We need all three of the letters to be present in any number in any combination. So we need to use the and operator. Okay, let's uncomment our where clause and let's replace this first line of pseudocode with some actual code. Description like, and it needs to have the pattern any number of characters, then a Y, followed by any number of characters, so there's a Y in it. One other twist, though, is some database systems may be configured to be case sensitive. So if I compare this with a lowercase y and it happens to be an uppercase Y, I wouldn't get a match. So let's ensure that that is going to match by casting the description to lowercase. All right, let's test this. We should get some results. We're only testing for Y alone right now, but we should see the result set diminish. And we do. Good. Okay. Now let's add our second criteria. And at the same time that this is true, we want to have the lower description like %u%, and let's test that. And again, our result set diminished, but we still have results. Our logic is working. And let's go ahead and finish it off. All right, so there is actually one product that matches that criteria. It has a Y, a U, and an M in the description, and that is Chewy Lemon Head Fruit Mix. All right, we're not quite finished yet because our specification said that it wanted the 0.01 formatted as a currency value. Now, we could, I suppose, simply make the string look like a currency value. And that works. But let's go ahead and do this like professionals. And we'll add this in to do a formatting on this value as we've learned to do. And so we need to do this two ways, one for SQL Server and one for MySQL. Let's start with the SQL Server version. And so let's use format on that 0.01 expression. As currency in English US units, that will give us dollars. Great. And usually I edit out the reconnection between SQL Server moving over to MySQL. Some viewers have asked to see that step that I'm using the Heidi SQL client for, so I'll show it this time. So you notice that I'm currently connected to SQL Server. We just solved the problem for SQL Server, and I will simply unplug that connection and connect it to my local MySQL server. And now I'm ready to convert this expression so it runs in MySQL. So let's take it down to the bare bones expression. And in MySQL, we will first concatenate a $, and then format the expression to 2 decimal places, and test it. And there it is, the solution for MySQL.
Thank you for watching. Please visit beckplanet.com/books for additional free student and instructor learning resources, a free ebook copy of Beck's Introduction to SQL Programming, that Pelican database book, and to learn more about print editions of the textbook and workbook.